All right, we're going to get starting. For those of you that are tired of hearing the announcement, if you're here for the TCP/IP talk, I have nothing but disappointment for you. Unfortunately, the gentleman who was supposed to present it couldn't make it, so I'm your substitute, at least for now. This talk was originally scheduled on Friday, I think at 1 o'clock, and we're going to be talking about DevOps at scale in the form of a Greek tragedy. Let's see. Well, I'm sure we'll dim the lights. So DevOps at scale and Greek tragedy. Why a Greek tragedy? And by the way, I brought some cool SignalFx t-shirts here. So if you have a good question or a good answer for one of my questions, you'll get a t-shirt. It may not be in the style or size that you'd like. You can come to our booth right by the entrance and exchange it. Hopefully I don't run out, but hopefully I will. So who knows what's so special about Greek tragedies? What's unique to that style of theater? Yes? And what happens at the end? Everybody dies at the end, exactly. That's what happens in most companies and their attempts of operating DevOps at scale. And that's what we're going to try to talk to. My name is Leonid Igolnik. I run engineering for a company called SignalFx. We have a booth here, and we'll talk a bit about what we do later. You can find me on Twitter at @Igolnik. And I've been in this business for 20 plus years, kind of pre-DevOps, pre-SaaS. I've been doing software as a service for many, many years. So I'm going to share some of my experiences with you on what it takes to scale the team and what it means to adopt a DevOps process at scale. So we're going to start from the very beginning. And the beginning is, what the hell is the DevOps? Like, everybody has their own definition, right? And because Greeks loved Venn diagram, we're also going to use a Venn diagram, right? How else could you define DevOps at scale? So there's a traditional Venn diagram, right? DevOps is the intersection between development, operations, and QA. Any test engineers in the house? Make some noise. No. Well, they also forgot about them. It's interesting. Everybody who talks about DevOps, I just had a conversation with John Villas, one of the guys who wrote the DevOps handbook, and we were talking about, like, how come DevOps forgets about Q? I guess the name didn't work, like DevQOps, QDevOps, and now there's this new movement. If you haven't seen John talk, he talks about DevSecOps, right? How to weave security into the continuous delivery process. I don't know what they're going to call it. For now, they keep calling it DevSecOps, so there's no QA in there as well. It's kind of strange. Today, though, we're going to take a different view of DevOps, and we're going to talk about DevOps as an intersection. So that's DevOps today, right? We're going to talk about DevOps as an intersection about technology, process, and people, right? Because those are the three things that tend to change the most as you scale, right? That's what we believe for the purpose of this talk. And when I say we, this talk was written by me and one of my collaborators, Baruch Sodogorsky, who is the developer advocate for JFrog, the guys that make Artifactory, right? So DevOps is this intersection between technology, processes, and people, and that's where you have to change the things to adopt it, right? So we're going to talk about our tragedy. Will take us through trials and tribulations of this mythical company called Pentagon Inc., right? Pentagon Inc. is in payment processing business, much like some of our their competitors that have a very similar shaped like logo, but it's not a pentagon. There's another reason why the founders called the company Pentagon, right? So without further ado, why don't we jump into our first act? We're going to call it the Fire Brigade, or reactive operations. So in order for us to understand what's happening in the company, at the beginning of every act, we're going to set the stage, right? So let's set the stage for our first act. So people, right? Remember, people, process, tools, or maybe people, tools, process. We'll see what order the slides are in. So company just got started. We got 3 software engineers who decided to quit their jobs and started a company, right? Pretty normal stuff. Well, they also happen to come from an on-premise background, right? They've never done kind of any online software. They built on-premise software. They used to work for defense industry. Maybe that's why they called the company Pentagon. Who knows? And, you know, they're pretty smart people. They go to conferences, but because they came from defense industry, you know, they miss the modern software aspects of that. They may still be working on EGB back in their old job. Yeah, but so they're kind of hipsterish. They go to conferences, they see all this cool tech, so they adopted this cool tech, right? They went with JavaScript, Node.js, reactive. Of course, everything is in microservices, and of course, everything's running in containers, right? Like, compared to what they used to do, like giant WebSphere servers, This kind of seems pretty cool, right? Pretty typical if you start a startup today, I guess. Process, well, what kind of process do you expect for a company of 3 people? At best, they have Kanban, and at best, they have that Kanban somewhere on the board, but probably most of it is in their heads, right? What's in flight, what do we need to work, et cetera, et cetera. So not a lot of process, probably don't need it, right? Now, the smart engineers, they know that TDD is important. They know that unit and integration tests are much cheaper and easier to get started up front. So they do so, right? They start with development, with test-first mindset, the right unit tests, the right integration sets. They realize that those things, as you continue to progress and increase the scale of your system, they build on each other, right? They go to those conferences, they hear those buzzwords, serverless, no ops. And of course, remember, they came from a defense industry. They used to have operations people that were like the naysayers. You throw the software over the wall to them, and you have to wait for like 3 years to get a server, or like you have to fill a change request to get this thing deployed to production. Anybody worked at a company like that ever? Yeah, I see some hands. So of course they go like, we don't gonna have any of those ops. Why do we need them? Like serverless is the thing, right? Like we got Amazon. Tools. Pretty simple tool chain. Like they decided to pick up Jira, and the one was GitHub. Who doesn't know what Travis CI is? I will explain. So, okay, in a nutshell, Travis CI is your Jenkins in the cloud. Like it's another CI server. And then they went with AWS Beanstalk. Beanstalk is the offering from AWS that will take your deployable, deploy it, auto-scale it up, down, you know, magical. No ops, no servers either. So let's see what happens. So who can tell me what is the first thing you do for a while after you start the company? What's the first thing you have to do? Pay taxes? Well, maybe. Depends on the country. Hire people? Well, no, they don't have any money. There's just 3 of them. What else? Well, first you have to build the product, right? Then you have to find the client. And the finding the first client can be quite some time. So you got to wait. And you wait, and you wait, and you wait. And then you find your first client. So what do you do? What's the first thing you do after you found and onboarded your first client? Sorry? Failed to deliver. What else? I heard something on the right. Celebrate. Of course you celebrate. And if this was later in the day, I would have pulled a bottle of something, and I would start drinking with you as well. Baruch and I quite often do that when we do this talk, right? And it so happens that their first client was this great conference in Poland who hired them to do payment processing for their tickets. All right, so they're very happy. They party on Thursday. Friday night, Adrian Novak, one of the key organizers of this conference, gives them a call. Guys, I'm trying to sell some tickets. Are you crazy? Nothing works. Like, I cannot sell a ticket. We have this major promotion going on. What the hell are you doing to me? Nothing works. What do you do when your first client, your biggest client, because you only have one, calls you with that? And what's your next reaction? You panic. Of course you panic. Somebody must have seen my talk, or somebody has lived through this. We'll have to check. But yeah, of course you're first buying. What do you do next? You charge. So, they all go into production environment. Well, the first question is like, what the hell failed? One of them asks the other, so where are the logs? So, I don't know, in the cloud, somewhere there, because it's serverless. There was like nowhere to log into. So they read some documentation. They find that there's this thing called Amazon Cloud Watch Console, and they go into it, and of course the logs are per microservice, right? There's microservices. There's like tiny tons of little directories. You have to go with the logs, and they go, one of them goes, hey, Krzysztof, I've got this error at like 4 a.m. in the morning. Maybe this is the root cause. I'm like, yeah, I have something similar, but it's at 3 a.m. in the morning in the logs. This makes no sense. And then they realize that the servers are not in the same time zone because they're in different regions. Anybody had done time zone acrobatics while trying to? Oh, yeah, I see. Yeah. Well, some people have had some experiences. Time zone acrobatics are the best, especially if you do them at 2 a.m. in the morning after you partied hard. I've done that. So they look at this and they go, okay, so what happened? Apparently Krzysztof, one of the founders, has the great idea after the party, after they onboarded the new customer, so they went and committed the code. Well, what do? Well, you roll back, of course, right? So they roll back the commit. They try to build, but the bloody code doesn't build. How could that be? So they keep digging, right? This is Node.js, tons of JavaScript libraries. Go, hey, listen, there's this thing missing called left pad. Anybody remembers the NPM gate scandal, right? JavaScript developers, they like transitive dependencies. Like I looked, like at SignalFx, we have 1,200 components as part of the UI. Some of those components are 3 lines of code. There was this developer who got really pissed at NPM as the company and pulled this library called leftpad. What people on the internet didn't know is half of the internet dependent on the bloody leftpad transitively. And everybody's build broke. I was in California, that's where I'm based, and we were watching this during the day. It was like half of the internet couldn't, like all the CI/CD pipelines broke because like nothing would build. So they go on the internet, they find it in something, they find the archive, they find this leftpad library, they inject it back, and they get this built, they get Adrian happy, they sell some tickets. But at this stage of the company, the 3 of them, and this continues to happen time and time and time again. Right? Typically, when you start, and those of you who went through this journey are familiar, you tend to be in this firefighter mode, right? That's why this first stage is called the fire brigade. Now, if you want to progress, you inevitably either don't survive this stage, or you go to the next stage on the maturity curve. And we're going to call that stage the smoke alarm installers, or the reactive improvement stage, right? And we'll talk about what happens during the reactive improvement stage, but to do so, as always, we got to set the stage first. So let's see. What happened with people? We've got an actual funding round, right? The company is being more successful, so they got an A round. They hired 26 engineers. They realized that like this no ops thing is not a thing. So they hired an engineer who kind of has been around like operations, maybe has like deployed some servers, maybe when he was younger or she compiled the Linux kernel for fun, right? But they have somebody with that background now. They also have a couple 100 customers, so the founders are a bit tired of answering support calls, so they hire a support team, right? Well, that's logical. Like, why would you want to wake up the founder? Process starts to evolve, 26 engineers plus the original founders. That's kind of sizable. They start adopting some basic Scrum. They figured out that, exploratory testing is the thing, so they hire an exploratory tester. Does anybody know what exploratory, what else can be called exploratory testing, or what doesn't stand for? Sorry? Canary testing? No. Anybody? Clicking through the application, yeah, it's a fancy word for manual QA, pretty much, yes. Here, I'll get you a t-shirt. So yeah, it is important to have an exploratory tester because sometimes business applications, somewhere over there, I'm sure you guys can pass the t-shirt, sorry. And again, if it's the wrong size or the wrong design, come to our booth, we'll exchange it. Hey, they have an ops guy now. Like it's a thing, they figure it out, right? They also now decided that instead of waking out everybody, you have to wake up somebody. So they do what's very common at this stage, they introduce a developer on call, right? The 26 of them, you probably go on call every 26 weeks. Maybe they have a couple rotations. So at this stage, somebody gets woken up in the middle of the night. Oh yeah, they also figured out like this whole time zone acrobatic is uncomfortable, and because they have the guy that knows this op stuff, we'll call it, they moved all the logs into UTC where you don't have daylight savings and you don't play with time zone acrobatics. On tools, they got kind of Jira and kind of added Confluence. They realized that artifact management is a thing. You don't want to lose artifacts. You want to know what artifacts are in your system so you can recreate the state of the system. So they got an Artifactory server. They also figured out, got to get logs going. Because, searching through CloudWatch with the tools that Amazon gives you, God bless them, is not fun. And then they got this monitoring system called Pingdom. Very fancy, sophisticated set of monitors. Does anybody know what Pingdom does? Yes. What does it do? How does it know if it's broken? That's right. So Pingdom connects to your server from remote somewhere in the cloud, right? It's all serverless somewhere out there. And it basically goes, are you there? That's pretty much the best you can do, but it's better than nothing. At least at this stage, they will know whether their server is down or whether the entire system is down, right? Not bad, not a bad start. So let's see what happens at this stage. What does the company do when they raise a lot of money? I'm sure you know by now. Celebrate, of course. There's a lot of drinking going on in Silicon Valley. And then a call from the customer comes in. But it's a slightly different call. And the call goes like this. Hey guys, we are running a promotion And a lot of our customers using MasterCard are complaining, but none of our Visa customers are complaining. And the developer on call goes, well, like, there's nothing here. Like, Pingdom says green, digs through the logs, finds an error, finds a commit related to this error, some queue is overflowing, something. He knows that Krzysztof, the same guy from the first time, made some changes there recently, so he has to wake him up. Wakes him up. What does Krzysztof to do when he gets woken up and the key customer tells him that MasterCards don't work? Anybody? What's the next logical reaction? Panic, of course. And then they charge, right? They figure out that there was a commit, they changed and split the queues. They had queuing system for MasterCard and Visa to scale the system. And the queue is just too small. It's misconfigured, right? So they dump the queue because, you know, sucks to be the customers whose transactions are in the queue. They clear out the queue, they try to tune it. And then something new happens at this stage. The next day they get together and try to analyze the root cause, right? They try to figure out what has happened and what can we do to make sure that same issue doesn't bite us again. And that's the smoke alarm installing, right? Find the root cause of the problem, instrument it such that you're gonna get proactively alerted when this problem recurs again so you can find out about that problem before your customer does. Because there's nothing more embarrassing, at least for me, is when I get a call from a customer, and some of my customers have my cell phone number, and they say, hey, did you know that your system is down? That's kind of awkward, right? So what do? They tend to produce an incident report, right? How do they typically look? And this is one from one of my real products that I used to run. So let's talk about what are the key elements of a good incident report. So obviously you have the environment. If you have multiple, what was affected, right? And we actually obscured some of the details to protect the not so innocent, perhaps. You know, who participated in this? How long was the time? As you can see, this problem was running on and off for over 24 hours. And then we have this timeline of events. A lot of people ask me, so how do you get a timeline of events? Like, do we have a legal secretary sitting at the corner of like an incident room and like, you know, typing on her special funky keyboard that she can do? No, of course you don't, right? You do it a couple ways. Most teams that I know run some kind of Slack or some kind of collaboration tool. They typically have one channel for all the outage related stuff, or they have a channel per incident that they create. It depends on what you do. Some of them, like for example at SignalFx, if the incident is big enough, we'll jump on a Zoom virtual room because it's much faster to collaborate by voice while you type instead of just typing in Slack. So Zoom tries to, not very successfully, to transcribe some of the call, but somebody goes, typically in our case the engineer on call goes, and transcribes this chain of events. Having an accurate chain of events becomes extremely important, and I'll show you an example why, right? Then you start documenting symptoms. And the reason you want to document the symptoms is so you can put this incident report into the knowledge base. Could be as simple as a wiki, like Confluence. Could be something as fancy as PagerDuty's incident management tool. So you can actually search for this in the future, right? Hey, I have this thing happening in my system. What are the incidents looked like that, right? That's very important. And then you have an interpretation of what exactly happened and what has transpired in the system beyond like a very factual, detailed timeline. What do you do next? You document the root cause. Typically, in most cases, hopefully, you know the root cause for an incident. There are incidents that is unfortunate, it's very difficult to tell that to customers, that don't have a determined root cause. So what do you typically do in those? You instrument more. You try to figure out what else you can do to debug it next time it happens. Because when you run into the same problem multiple times again, your customers will not forgive you. And customers can forgive you a lot. And I'll show you a fairly drastic example of that. And then lastly, you have to document action items. So in our case, next steps, we were running Rally. So there's several defects were documented, including making a process for certain things. And you better have a process that you can follow and explain to customers what have you done to make sure that this problem will never happen again. So, in the case of our incident here with MasterCard, what do? We have to reconfigure the queue size. What should we do? What should we set it to? Well, probably 42 because it's a prime number in power of 2. I don't know. We don't have any other data. So 42 it is, right? Because at this stage, you rarely have enough information about your system to figure out, so you kind of kind of look at this and go, 42. 42 is always, right? So again, retrospectives are very important. The most important things about those retrospectives is be transparent with your customers on how you broke their system. The worst thing, who can tell me what's the worst thing a SaaS vendor can do to their customer? Lie. There's one more worse. Like typically, if you do this, you lose the customer. What's the biggest screw up a SaaS vendor can have? Sorry? Ignore. Now, there's worse. Anybody? Like what do the customers load into your system that is more valuable than the software itself? Data. So what's the worst thing you can do to your customer data? Lose data. Who said that? Let's get you a t-shirt. So, has anybody heard of a company called GitLab? Yeah. Major competitor to GitHub. This incident was happening in the middle of the day in Silicon Valley. And we were sitting kind of watching online, and we thought that's it. That's the kiss of death for GitLab. Because they didn't lose just one customer's data. They lost all customers' data. That was painful. That was really, really painful. They lost 6 hours of data. Most companies don't know or don't recover from a failure like this. And most of us, and I was chatting with my friends in the Valley, and we thought that's it. That's the kiss of death to this company. Now, GitLab did the best thing they could. They wrote a very detailed incident report, and they published it online. So that transparency, which is very, very, very painful because all of us as engineers, we want to be good at what we do. But we work on very complex systems, and they fail in unpredictable ways. So let's look at theirs. So we had the LLVM shadow, and regular backups seem to be taken every 24 hours, and nobody knew where the backups were stored. Oops. And by the way, the ones that they found at some point, well, they only had few bytes in size. That kind of sucks. On top of that, the binaries that were running the backups were the wrong binaries, and therefore the backups were not running. But don't despair. Wait, never mind. All backups were cleaned up by some shell script. And then they said, okay, we have disk snapshots, right? At worst, will they restore the database from a disk snapshot? Yeah, somebody forgot to enable them for the database. And then we have a synchronization process, but it's like duct tape and baling wire and a bunch of shell scripts that Billy wrote and left the company 5 years ago. Nobody knows how it works. Yeah, it didn't work either. And they had another backup to S3, but the bucket was empty. And 5 different backup replication deploys. So they had 5x redundancy on this process. Right? Nothing worked. So they had to restore from 6-hour old backup. If you don't handle the root cause analysis and you don't promise your customers and you don't explain to your customers how you're going to make sure it doesn't happen again, they will never trust you with their data. Data is more valuable than gold. You can fix a software bug in an hour. Anything that destroys data tends to be a kiss of death. Now, GitLab recovered. Probably felt like that. I know if I had an incident like that, I would feel like that. But Jesus, who is the team member 1 who has deleted the database, actually got a lot of re-encouragement because of the transparency, including gift from Google, a gift card from CodeFresh. People rallied around the company because the way the company handled the incident. On top of that, at some point, team number 1, Jesus, was actually slated for a promotion. Company did the right things. It's not the human who broke the process. It's the process who allowed the human to do something wrong. So blaming the human is not the way to evolve your process, right? And it so happens that he also changed his title on GitHub to the coolest title I can think of. He's now database removal specialist at GitLab. All right. So that's Act 2, and we'll talk about Act 3 in a second. So the key thing about this stage, right, the smoke alarm installing, is installing a repeatable process and sufficient amount of tools that allow you not to make the same mistake again, and learning how to be methodical and transparent about the mistakes you made in the past, and convincing your customers that you will never make mistakes again. I'll give you an example from personal call a few weeks ago. SignalFx has a lot of still Elastic 2 in our environment, and we handle petabytes of data, and we have billions of records in those. And Elastic 2 is a nightmare at this scale. And we're migrating to Elastic 6, but we had an incident. I was fortunate enough, I was talking to one of my customers, and because I was transparent with them, and I told them, like, listen, this is what's happening, here's the plan, here's the Jira dashboard outlining the plan. He looked at me and goes, yeah, no, I know, trust me, dude. We're dealing with Elastic 2 as well, right? I could have told me, trust me, it's going to be okay. You don't need to know what happened under the covers. I didn't. I gave him more details, and I won his trust. So let's talk about Act 3. This is a Greek tragedy, right? Everybody must die. So let's see what happens at Act 3. Well, naturally, the company continues to grow. They got another round. They hired 74 more engineers. They actually hired engineers with Office background. They actually kind of built an entire team. And this is the stage somebody should stand up and storm on the room and say, Leonid, wait, this is a DevOps talk. What kind of dedicated bullshit are you talking about? How come you have an ops team? Isn't like DevOps about not having an ops team? No. DevOps about making sure that you build it and you own it, but somebody has to centralize some of the key knowledge and be the enabler of this process. And the role of the DevOps team in their organizations is to be that enabler so other teams that deliver software can become faster and can adopt the process easier, right? In order to do that, you need an engineer who understands software engineering and operations, right, and bridges that gap. And that's what a typical dedicated DevOps team will do. They also realized that performance, this scale is a thing, so they hired a dedicated performance engineer. They got a chief architect. Ooh, this is where everybody gets scared, right? Because normally chief architects show up to the office the first day with a little attachment to their car that has the portable ivory tower, so they can sit high. So yeah, they got a chief architect, and there's some changes because of that. But you can make good changes if you have a chief architect. There's this thing called customer success team. The role of the customer success team, it's a team within engineering, and their role is to be interrupted so everybody doesn't have to. So if support cannot solve the problem, or if there's a particular thorny technical problem, they take the first call, right? Because of that existence of the team, by the way, they're not the maintenance team, they're not the bug fixing team, right? They're the shield that protects the rest of the organization from interruptions. Because you have a centralized team that collaborates with support, it allows them to build that relationship with the support team and the relationship of trust. It also allows them to start observing certain patterns of issues that come up, patterns that are difficult to troubleshoot. Because they're software engineers, they can also build tools to help them overcome those problems or enhance the product, right? Some companies have permanent members of the team only. Some companies have permanent members plus rotation. Some companies have rotation, right? It depends on what fits you. They got legal now. They're like a real company, right? So there's a legal person. They have a CFO, right? Somebody has to watch the purse. There's a lot of money in the company now. Somebody has to worry about money. And about 1,000 customers. Process, well, Scrum works well at the team level, but how do you orchestrate multiple teams, especially if they're across multiple locations? For example, SignalFx has offices in Silicon Valley and Raleigh, North Carolina, and we've recently opened an office here in Krakow, R&D office. So you need a process that allows you to orchestrate something on top of Scrum so you can coordinate team dependencies, you can coordinate your deliverables. Safe is one of them. There's another one called Less. It can be very scary if you go to the website and you see the entire framework, but you typically adopt the lowest layers of the framework. And if you want to learn more about how we at SignalFx recently adopted the right elements of Safe, don't ask me. I'm the head of engineering. I'm probably not going to give you an honest answer. A bunch of our engineers at the booth talk to them. They also built a dedicated system testing team or quality engineering team. Much like the DevOps team, their job is to enable other teams to be successful with quality engineering. Somebody has to build the frameworks. Somebody has to think about how to think about quality methodically. I'll give you an example. At SignalFx, we have a customer. We launched an APM product in November. And there's a measure in that APM product how many spans per second we can consume. And we can consume about 100 million spans per minute. And we have a large customer who wants to buy that product, and he goes, hey guys, how quickly can you get to a gigaspan a minute, 1 billion spans a minute? Well, a team like quality engineering, at least at SignalFx, is the team that builds a load generator, because by the way, building a tool that generates 1 billion something a minute is its own engineering undertaking, right? So the team that builds the product can make sure that it can test it and scale test their product. That's the kind of things you do with a dedicated quality engineering team, system test team, if you want to call them, not centralized QA team by any means. We talked about it, right? They have this like the ops team thing, right? Again, centralized enablement, tooling, understanding how to run Kubernetes, dealing with AWS, dealing with GCP. because they are on call, and they're big enough, they have an escalation path, right? So the person on call knows who to wake up in the middle of the night, right? That on call typically goes all the way to the CEO, and if there's a slot in the conference, if enough people want it, I have this talk about making on call suck less. It's called Silicon Valley Chainsaw Massacre, or how I spent my Friday on call. This is a recording if you want to watch. So there's an escalation path and there's a manager on call. Why do you need a manager on call? If you have a major incident, you have to have somebody fix the problem, and while somebody else can communicate to customers in other parts of the company. They have SOC 2, ISO 20001, I don't know, PCI DSS, name a compliance standard. They probably have something like that as you go to that scale, because your customers are starting to ask for this. Of course, the tool chain has to evolve. Oh, yeah, they have this thing called non-functional backlog. Remember, the chief architect was the ivory tower. So his job is to help the team make sure we have cohesive architecture, and his job is also to manage the technical backlog that comes out of the engineering team. So when we do the planning, the technical backlog can be merged correctly with the product backlog. So we're not just working on features, but we're also working on enhancing the system as it needs to scale. Of course, the tool chain has to enhance. They've gotten some configuration management, maybe something like Zookeeper. They've gotten something like SignalFx or any other monitoring solution, because remember, in the previous stage, well, 42 was the number, because if you don't have the data and you don't understand how your system behaves, it's very tough to tune it. Krzysztof got promoted. He's now the head of engineering. Judging by the quality of the congratulatory card he got, maybe the team was quite ready for him to stop coding, because he seems to be creating all the problems. So let's see what happens. I'm sure you can guess what does happen when the company, what typically happens when the company raises money? Of course. And then something different happens. Friday goes by, Saturday goes by, Sunday goes by, Monday goes by, there are no major storms, alerts happening, people on call respond, they deal with the problems. But then head of legal comes to Krzysztof and goes, hey, Krzysztof, I just got back from a legal conference. Yeah, they actually have conferences like that. You know, they sit in the room, they talk about limitation of liability, LGPL 2.1, Affero GPL. And she goes, hey, listen, I just came from this conference, and do we have any Affero GPL and a GPL in our code? What does Krzysztof do? Of course. But then he remembers, I'm the head of engineering now. I have people, so he tells the entire team, charge. Go look through all the POM files, all the JSON files, and figure out all the components we have, because there's no system to track it, and all the licenses, and go figure it out, right? And then the next day, the head of the CFO comes and say, hey, Billy, Krzysztof, we are planning financials for the next year. How much money do we need to run the production environments if we're going to sell that many customers? Well, Krzysztof doesn't know, so naturally he has to panic first. And then he kind of remembers that no CFO ever refused money for production environments, especially if you have customers that you keep selling. So he goes, 42. Why 42? Always, right? Prime number, power of 2, all those good stuff. And then the last thing happens. Does anybody know who this is, by the way? Like, I always argue with my co-author of this talk. Like, if you have to explain the joke has to go out of the talk, but he refuses, so we have to keep it. This is the guy. There's an awesome channel on YouTube called Will It Blend. It's a company called Blendtec. They make amazing blenders, and the guy, I think, blended everything from phones to tablets to brooms. Go figure. So the head of sales comes to Krzysztof and goes, hey, Krzysztof, we have this biggest customer, biggest customer we could ever dream of, but they're concerned. They're not sure if it will scale. Will it scale? Or will it blend, as the channel does? Well, of course, Krzysztof doesn't know. So first he panics. Then he remembers, I built the system. I know something about this. Goes to his engineering team and goes, hey, guys, do you think this will scale? They kind of look at the data they have and go, nah, of course it'll scale. We built this. Well, of course it doesn't, right? And that's where the company dies. Now, because this talk was written for North America, we cannot just leave this as a traditional Greek tragedy where everybody dies. We should really talk about a happy ending. So this is, for those of you that don't know, Smokey the Bear is the fire prevention mascot in the US. And we'll talk about the last stage that you need to reach in order to continue to scale. And that stage is called proactive improvement, right? So we went from reactive to reactive improvement to proactive improvement. So what happens when you reach that stage? You start doing performance and scalability testing more proactively, right? Because you're starting to get into the types of system changes and customers that you probably don't know how they're going to influence your system. You start tracking your licenses. You start getting better about your security, vulnerability scanning, and vulnerability impact processes, right? I'm sure everybody heard about Equifax breach, Struts 0.20. My data was in that database. We're starting, because we have some system that has some data, to watch performance trends, right? And we start doing them on the periodical basis so we can be both proactive about scheduling non-functional work that requires system to continue to scale on this trend. Also, we can predict how much hosting we need, how much servers, how many engineers, et cetera, et cetera. You start having something called non-functional definition of done, right? Then I assume everybody knows what definition of done is in Scrum, right? That's when the story is done. But non-functional definition done talks about all of those abilities that tend to be forgotten, and that's why the chief architect has to drive it. It's, hey, if you want to launch a service, it should have a health check. It should log in a standard way. It should emit some standard metrics. It should be instrumented with some standard tracing solution, right? Ideally, you can have your definition of done coded in some kind of artifact from which you can inherit. A lot of shops I've seen do this by having a base Docker image from which everything gets built. But you absolutely start needing it, because if you have a lot of team putting code in production, you need some consistency. So the person who wakes up at 2 a.m. When they get paged, probably half drunk, can figure out what the problem is without knowing the intimate details about the system. Your tools tend to evolve as well. You probably get something like JFrog X-Ray, which automatically extracts all the licenses from all the components. You get some load testing service, or maybe some service virtualization, which like a mock for remote APIs. So you can better automatically test your systems. And you can continue to grow as you continue to scale the team. Right? Now, the biggest and most important part of this stage is starting to rely on data to make decisions, right? Because as the company or as the team continues to scale, you have a lot of priorities. One of my favorite tools to do that decision making based on data is a very sophisticated, very expensive tool made by this company called Microsoft, and it's called Excel. And all of you probably have access to it, or Google Docs, right? Like, here's an example of how you can use Excel. This is from a real product I used to manage. We looked at where we're spending our capacity, right? And how we're investing our time, and are we investing in the right places? And like, we had 6% investment in engineering velocity, 8% customer mean time to resolution. We had a giant swath at this stage keeping the lights on. And then we had this big feature A, which everybody was surprised. Wait, we're building this big feature A, we're betting the company on this thing, and it's only 13% of our capacity, right? That doesn't make sense. So looking at the data is always the right way to make decisions. Here's another example for you. From a real conversation with the head of support of the company that I used to work with. Hey, listen, he comes to me and says, Leonid, the quality of our product sucks. I can hear some data for you, like customers are opening incidents. A lot of them are severity 1, severity 2. Again, Excel, very sophisticated tool. So 65% of issues that came in from support to engineering were severity 1, severity 2. Like, those are fairly giant numbers, right? So you look at this data, what do you think about the quality of this product? Is it great? Sorry? Yeah, it doesn't seem great. Is there enough data here to make a decision what the next step? Should we be fixing the code? Should we be changing the architecture? What do you do, right? Typically, you need the right data to make that decision. In our case, the right data was to try to figure out what causes those incidents and how we respond to those incidents. So if anybody here was ever made to make sure you set up the correct resolution when you close the bug in Jira, you'll understand why, because that's what we had to do. And then we'll look at this data with that projection, and it's the same data, except that you'll see that only 19.9% of the defects that support created resulted in some kind of code fix, and 52.3% were closed with this resolution called information provided. Does anybody now think that like quality of the core product is the problem? Not really. What would you do if you saw this data? What would your next step be to fix the number of high severity incidents? Write documentations. What else? Hold on a second. Let me get you. Who said that? Where's the... okay. Almost. What else? Improve UX. Sure. What else? Training for who? Exactly. Who said that? Here we go. Training for the support team. And that's actually, that's what we ended up doing. I actually took an entire Scrum team of engineers after talking to my head of product management, say, hey, listen, why don't we take a team offline for a month, go train support, and I'm gonna give you all of this time back, right? If I didn't have this data, I would never be able to convince a head of product management to invest in this. You will never be able to convince your product managers to invest in technical debt or quality. Bring data to the table if you want to get to proactive improvement, and that's the key to this stage. So we have 3 slides left. Perfect, we're running on time. So let's talk about the EPI Myth of this story. Who knows, by the way, what EPI Myth is? No Greek literature majors, I see. Anybody wants to try to tell me what EPI Myth is? Come on, you probably can figure it out. Sorry? Summary? Yeah, close enough. Anybody else? All right, we'll go with summary. The EPI Myth actually in Greek stands for the moral of the story. So I have a couple things for you to take away. One is really strange. Scale is a scale. I'll let you ponder on that one for a second. But the real truth of this process, and I've done this many, many times with different teams, that you cannot skip stages on this maturity curve. You have to go through reactive improvement before you can get to proactive improvement. Because getting from stage to stage requires you to add additional process, additional people, additional tools to the mix, so you can move from reactive improvement, or the fire brigade, the fire brigade. You can move to reactive improvement, or the smoke alarm installing. And you can become Smokey the Bear, the fire prevention musket, and move to proactive improvement. A few others. Remember, DevOps is not about dev, QA, and and ops. It's about tools, processes, and people, and it's about change. You want to get better, you have to learn how to change the organizations, you have to learn how to influence yourself and influence others to move that change forward. You typically do it by adopting some key taglines. Some of them are very traditional, like you build it, you own it. Some of them are less traditional. Data is a key, right? Excel is fine. And my favorite one, and I have some members of my engineering team here and they know this, it's called pain is instructional. Nothing made me build better code and write better debug and better logging than waking up at 2 a.m. in the morning and realizing that only if I put that bloody log line in there, I wouldn't have spent 3 hours troubleshooting the issue. Pain is instructional. If it's painful, do it more often. You will get better at this. It will be less painful. It's no different than going to the gym. With that, thank you for your time. You can find me on the internet at Leonid Igolnik. SignalFx is at SignalFx. This has been GeeCON 2019. And last, I'll leave you with this. SignalFx is in town. We opened an office in January. We have a booth here. You can get some cool t-shirts there. That's our office. We're somewhere in Novi Klepash on Luga 72. So come check us out if you want to learn more. And now we have time for questions. Let's see if this, well, I don't know if I need to log in into the tool or if the tool will be logged in. Or you can just yell your question. Yes? Yeah. So the question was, by the way, good questions also get t-shirts. We have hundreds of those. So the question was, how do you onboard a new team, basically? How do you pass knowledge from highly trained, highly knowledgeable people to people that you just joined? And actually, that's a problem we just talked about recently at SignalFx because we opened an office. We're in California. We're on the East Coast. We're certainly far. What we tend to do is we mix people around. So we mix teams, we mix experienced and inexperienced people. We fly plenty of people back and forth between California, East Coast, and Poland and US, right? We have folks spend time there. We carefully think about onboarding projects. Documentation becomes a key. Collaboration tools become a key. When I joined SignalFx, for example, we were on Hangouts, and unfortunately, Hangouts just sucks, right? Especially if you have to collaborate with remote office. Video is a key as well. So we moved the entire company to Zoom, for example, to make sure we have proper video conferencing, we have whiteboard sharing. You have to worry about, in our case, we have to worry about adjusting time zones, right? We're 9 hours away, so some people here time shift, some people in California time shift. And then it takes time. You have to find the right projects that also move the teams that you, or the new engineers, whether it's locally in California or here across the pond, slowly along the sophistication and the complexity curve, right? Because there is nothing more frustrating for engineers to join the company and see result of their work in 3 months. So I am a big believer that you join, day 1, you get your HR paperwork done, day 2, you set up your development environment, day 3, we love an engineer to be able to fix a bug, right? Now, that requires having a dev tool chain that can be set up like that and you can be productive. But it's something exciting, right? I just joined a new company and on day 3 I produce something. And because we continuously push to production, that bug is in, like the fix is also in a production environment. Those are the kind of things that we do to make sure the process is less painful. It is painful regardless, right? But it is motivating for engineers to do work. Like I remember when I got into coding when I was 12, I'm like, I can type some things on this machine and it does what I wanted to do. That's kind of cool, right? Same for most of us engineers. And therefore, that's how we try to set up the process. Demonstrate some return on investment. Like somebody here who joined SignalFx in Poland a couple months ago, just built a key feature that allowed us to, we recently Lyft, one of the ride-sharing companies, recently joined us as a customer. So one of the engineers who joined here built a key feature that allows us to close Lyft, right? And he's pretty excited. Now I know he's going to be engaged for the rest of his career with us. Those are the kind of things we tend to do. What else? You can yell your question if you have one. We've got 3 minutes and 11 seconds. Yes, one more. So the question is, when a major incident happens, what's the reaction of the people? I think it depends. I worked with all kinds of teams. Some kind of get rallied by a problem and get together and try to figure out. Some need some help, right? There's this blame game that starts, right? That's not healthy. So you have to work with individual teams. Remember, DevOps is all about change, right? So how do you change the behaviors? How do you motivate the right behavior? It's very situational. All right, it sounds like folks are quite done. I'm probably standing between you, some coffee, and some other talk. So thank you very much for your time. It's been a pleasure. And for those of you that have the t-shirt in the wrong size or the wrong kind, we have 2 styles. Come to our booth. We will happily exchange that.